So this is lesson 1 in the probability unit for Workplace Math 10. We're talking about experimental probability today. So first, a couple of definitions before we start. This is our first lesson on probability, so we want to talk about some of the key terms we'll be using. So let's start with the word probability. So when we say probability, it's the chance of something happening. We'll call the something an event. It's the chance that something happens, and we write it as a decimal, a percentage, or a fraction. And the way that we calculate the chance that something's happening is we look at the number of ways that it can happen. Sorry, I'm just gonna... divided by the total possible outcomes. And we're going to do some examples of that. So a way that you might say a probability is you might use it as a percentage, like you might hear on the news, or you might look up the weather on a weather app, and I might say there is a 40% chance of snow today. Or you might roll a dice and you might say the probability of rolling a 2 is 1 out of 6. The reason it's 1 out of 6 is because there's 6 sides to a die. So when you roll the die, there's only one way to get a 2 out of a total of 6 possible things that can happen. Okay. Experimental probability is when we actually run an experiment. Okay, so you actually roll the dice or roll the die a certain number of times and you calculate how many times an event happens. Okay, so let's say, I'm going to do an example here. Let's say we flip a coin 50 times. Now you would expect that half the times the coin's going to come up heads, half the time it's going to come up tails, but due to random chance, that might not happen. Maybe the coin lands on heads 20 times. So we say the probability, the experimental probability of getting heads maybe a little bit lower than expected, is 20 out of 50, because the heads showed up 20 times out of 50 possible. So we can reduce that. So we divide by 10. So a head showed up 2 out of every 5 times, or that's 40% if you change it to... So experimental probability is what actually happens, and theoretical or just probability itself before you've actually run the experiment. It's kind of like what you expect, that you can calculate. So those aren't always going to match just due to random chance. Okay, so let's do some examples. So another key term here is expected value. That's what you're going to expect to happen. So it's the number of times you expect an event to happen for a probability. So let's say, here's an example. Let's say 30% of the candies in a jar are red. So if you pull out 20 candies, how many would you expect to be red? Okay, so you would expect 30% of them, of the 20 candies, to be red. I mean, not always going to be true, but this is how you would do it. So on your calculator works in decimals. So the fastest way, I think, to calculate 30% of 20 is you want to change it to a decimal by dividing by 100. 0.30 of, when it comes after a proportion like a percentage, it always means multiply, and then 20. So that's what we're going to do in our calculator. I'm going to just turn it on here. 30% times 20, 6. So we'd expect 6 candies to be red. Again, not always going to happen due to random chance, but that's what we'd expect. Okay, let's do some more examples here. So it says a grocery store sells 3 types of apples. Last month, excuse me, they sold, I'm just going to use different colors, 75 pounds of brand A, 110 pounds of brand B, and 15 pounds of brand C. So it looks like brand C was less popular. What's the probability of a customer buying brand A? Write your answer as a simplified fraction and as a percentage. Okay, so first we need to figure out the total number of things that can happen. So the total number of pounds that people purchased. So we want to add up all of these numbers. 75 plus 110 plus 15. That's 200 pounds. Okay, so the probability that a customer buys brand A, and for short, we just use a big P here when we're talking about probability, and we're talking about brand A here. So that's why I put brand A in the brackets. So this says in words, if I'm going to read this out, the probability of brand A being chosen is going to be 75 out of 200. That's because 75 pounds out of the total were brand A. So we're going to reduce that just by dividing by 25 here, because both numbers can be divided by 25. We get 3 out of 8. Now, if we use our calculator, we can turn this into a percentage. We're just going to type 3 divided by 8, and we get 0.375. That's the decimal version. Now, to change that to a percentage, all I have to do is make it out of 100, times it by 100. So that just moves the decimal over 2 spots, and I get 37.5%. So the probability of pulling, or that a customer chooses brand A, is 3 out of 8, or 37.5%. Okay, let's see the next question. It says if the store sells 500 pounds of apples next month, how many pounds of brand C are they expected to sell? So first, what we have to do is figure out the percentage for brand C. So brand C is they sold, the probability of getting brand C, they only sold 15 pounds of brand C out of 200. If I turn that into a decimal number, it's 0.075, or 7.5%. So only 7.5%, the way I did that is I just moved the decimal over twice. So only 7.5% of the apples are brand C. So what we'd expect is 7.5% of the 500 pounds. LBS is pounds for short. 7.5% of the 500 pounds to be brand C. So we take our percentage, we change it to a decimal, and we multiply by 500. So we take that number, 0.075 times 500, 37.5. So we'd expect 37.5 pounds to be brand C. Okay, key concept. This is really important. When we're using experimental probability, when we're running experiments, there is going to be some random chance. So sometimes results are not going to be exactly what we expect. But if we do a really big sample size, the results are going to get closer and closer to what's actually expected. So the larger the sample size, the more reliable the data is, or the less random chance. Okay, so I'm going to put in brackets less fluctuations due to random chance. So if you only have a small number of data points, there can be a lot of fluctuation from what you'd expect just due to random chance. But if you have a big data set, then your data is more reliable. Okay, let's read this one. Sarah's a high school student in Burnaby, BC. 9 out of her 10 friends play soccer. Let's just highlight that. So she concludes that 90% of Canada's population plays soccer. Do you think this is a logistical conclusion? Okay, so 9 out of her 10 friends play soccer. 9 out of 10. Let's convert that to a decimal. If I divide it, it's 0.9, which is 90%. But this is a very small sample size. only 10 people compared to about 40 million people in Canada. Oops. And, sorry, I'm trying to erase that M. Very small sample size. That means very small data set. So the data is probably not reliable. Also, it's a very specific group of people. It's her friends. So if she plays soccer, she probably is friends with people who play soccer too. So it's not like a good data set that represents all the different types of people in the population. So the data is not reliable enough to make this conclusion.